students, so after completing first problem, let's move to the second problem on the higher order differential equation when right hand side is a polynomial. So let's apply the rules which we have learned in the previous video and let's solve this numerical. So here we have the linear differential equation with constant coefficient as d cube y by dx cube minus 2dy by dx plus 4y equal to 3x square minus 5x plus 2. Now guys, to get the answer of this question, observe the right hand side, and the right hand side is a polynomial. So whenever we have the polynomial, that time we have set of rules which we will apply to get the solution. What are the rules? So here on the screen you can see the rules. It says that rule number 1 is we have to find out the complementary function or YC. Then rule number 2 will find out the particular integral. So let's start. Let's find out the complementary function of the given higher order differential equation. So for that we have to find out the auxiliary equation, and we get the auxiliary equation by equating f of d to 0. So for that I'll convert this given left hand side in terms of operator d. So d cube by dx cube is given by d cube y as it is. This is negative 2 dy plus 4y. Remaining terms as it is. So here we got the function of d will equate to 0 to get the auxiliary equation. Now let's solve this auxiliary equation. So guys, here this auxiliary equation is a cubic equation. So to get the roots, there are two methods. Use the calculator. In calci, put this cubic equation. Calculator will give you 3 different roots. That is one way. And the other way is use the synthetic division method by which you can get the root. So here I'll be using the synthetic division method so that even if you don't have calculator in the examination, still you will be able to solve this question. So accordingly, in synthetic division method, we write the coefficient of all terms. So here d cube is having coefficient as 1. Then d square term is not there, so the coefficient is 0. Then for d the coefficient is minus 2. And in the end we have the constant, that is 4. Now guys, according to this synthetic division method, what we do is we take the different roots over here and then we do a process of multiplication and addition continuously till we get 0 in the end. So generally I suggest to student that start with 1. If 1 is not working, then take negative 1. If it is not working, then take 2 and minus 2. Now in this case I'll be starting with minus 2 because I know the roots of this equation, so that is I'll directly take this minus 2. Now 1 will come here. Next 1 into minus 2 is minus 2. So I'm doing the multiplication. But before that what I did is I copied the first number as it is. So rule is you have to copy that first number as it is. Then multiply, which is minus 2, and then we'll add. So multiply and add, multiply and add. This is a process that we are going to follow in synthetic division. So minus 2 plus 0 is minus 2. Then minus 2 into minus 2, multiplication is 4. Now we'll add 4 plus minus 2 is 2. Then we'll again multiply. 2 into minus 2 is minus 4. Then we'll add. And guys, here we will get 0. So that is why minus 2 is our one of the root. So we can rewrite this term as One factor is d plus 2. Now guys, observe, since the root is minus 2, in the bracket I am writing plus 2. So that when I equate this to 0, I will get d as minus 2. Next, remaining 3 terms. So this is 2. This term I'll multiply by d, this term I'll multiply with d square. So we will get d square minus 2d plus 2 equal to 0. Now we'll find out roots of this quadratic equation by using the formula. So here I'll say d plus 2 is equal to 0, or d square minus 2d plus 2 equal to 0. Now here we'll get roots as minus b. So b is minus 2, so that will become positive 2, plus minus root of b square, that is 4, minus 4ac. So 4, a is 1 and c is 2. So 4 into 1 into 2 is 8 upon 2a. So a is 1. Now d equal to, so the root of this 4 minus 8, that is minus 4, is 2i. So the root of minus 4 is 2i. Here we have 2. In denominator we have 2. We can cancel all 2's and we will get 1 plus or minus I. And from here we are getting root of value of d as minus 2. So guys, it means here we got 3 roots. One root is real and other 2 are complex and distinct. So let's find out the complementary function for this. So the complementary function, which is yc, is given by c1 e to the power minus 2x. So here we have written the real root. Now for the complex root, we write the real part as a power of e. So that is e to the power x, and in the bracket we write this imaginary term as an angle of cos and sine. So that will become c2 cos of x plus c3 sine of x, since the value of imaginary part is 1. So guys, this is the value of complementary function. Now let's find out the particular integral. So particular integral, which is yp, is given by the formula 1 upon function of d. Now here the function of d is d cube minus 2d plus 4. So here I'll write into the right hand side. So right hand side is 3x square minus 5x plus 2. Now if you see the right hand side, then it's polynomial, and whenever we have polynomial, we convert that denominator in the form of 1 plus or minus 5 of d raised to n. So here in the rules we have seen that we have to convert that f of d in this format. Now guys, to convert it in this format, here we have constant 4. So what I'll do is I will take that 4 outside, and then automatically here we can get 1. So I'll write this term as pi equal to 1 upon, I'm taking 4 outside. So that is why here we will get 1, and here we will get d cube minus 2d by 4. So 1 plus, now I'll take this 1 plus 5 of d in the numerator, so that will become 1 plus 5 of d inverse. Now guys, we'll expand this, that is 1 plus 5 of d inverse, by using the formula. So this is the formula of 1 plus d inverse. Now instead of d we have that function of d, some function. So the formula is 1 minus that function of d plus that function of d square minus that function of d cube, and so on. So here we'll get 1 by 4 in bracket 1 minus the function of d. So that is d cube minus 2d by 4 plus we'll have d square or function of d square. So this is the function of d. We'll say d cube minus 2d upon 4 the whole square minus so on, and in the bracket 3x square minus 5x plus 2. Now guys, here I purposely stopped the series, and the reason is simple. If you observe the polynomial, it is a quadratic equation. It means the highest degree is 2. So if the equation is having highest degree as 2, it means it can give us 2 derivatives. And if we try to find out the third derivative, that will be 0. So if we are not going to get the third derivative, or if we are going to get third derivative of 0, there is no need to write down the remaining term. So here I have considered till square because I can get maximum 2 derivatives of this term. So let's move ahead. So that will become 1 by 4 in bracket 1 minus this is d cube by 4. This is minus and minus plus d upon 2. Because 2 ones are 2 twos are. Now let's expand this. So guys, this is a minus b the whole square formula, which is a square minus 2ab plus b square. Now guys, if I do a square, that is square of this, that will become d raised to 6, which is of no use for me. Then we have 2ab. So 2 into this will become d raised to 4. Again no use. And then last term is b square, that is square of this will be 4d square. So here I'll say it is plus 4d square upon 16 because square of 4 is 16. So that is of my use because we can get the second derivative. Then minus remaining terms will put dot 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 and the function. Now let's find out the value. So 1 into this right hand side will be as it is. Then we'll find out the third derivative. But guys, third derivative is 0, so this term will become 0. Then we'll find out the derivative of this function. So derivative of this is 6x minus 5. So 6x minus 5 into 1 upon 2. So we will get plus 1 upon 2 6x minus 5. Then we'll find out the second derivative. So first derivative is 6x minus 5. The second derivative is only 6. So 6 into this. So this is 1 upon 4 into 6, that is 6 upon 4. So here we will get plus 6 by 4 and we'll get the value. Now guys, we just have to rearrange the terms and we have to take the similar power terms together. So 1 by 4 as it is. Square term we have only 1. This is minus 5x. This is 6x upon 2, that is 3x. So minus 5x plus 3x is minus 2x. Then here we have 2. This will be minus 5 by 2. So 2 minus 5 by 2 is minus 1 by 2 plus 6 upon 4. And then we'll say pi is equal to 1 by 4 in bracket 3x square minus 2x. We'll solve this. So by adding these two values, we will get here 2 into 2, that is 4 by 4, and we will get as positive 1. So guys, this is the value of particular integral. So we got particular integral, we got complementary function. Now the last step is we have to add both the values. So pi plus cf will be the final answer. So you can copy down these two values here to get the final answer. So guys, I'm sure that you understood the explanation. So keep watching the videos. In the next video, I'm gonna cover the next method of higher order differential equation. And if you want to watch more videos on Ekeeda, then don't forget to subscribe to our channel on YouTube, because there you can get access to all videos, and also you can get the updates about the new videos that we are posting. Also, don't forget to share this video with your friends, because they can also get benefit through Ekeeda videos. Thank you very much.